Hello everyone, welcome. In this video, we will look at another important serial protocol, namely the Serial Peripheral Interface, or the SPI. So let's get started. SPI is a synchronous serial communication protocol that allows multiple devices to communicate in a connector peripheral system. Like we saw in the previous video, serial interfaces transmit data bit by bit, which simplifies the wiring. Also, since SPI is a synchronous protocol, it has separate data and clock lines to synchronize data transfer between devices. This makes SPI highly reliable. Let's look at some terminology related to SPI now. The one which is common with the UART protocol is the bit order, and which can either be LSB or least significant bit first, or MSB or most significant bit first. If you recall, LSB just means that the data is transferred from rightmost bit to the left bit, and MSB means it is transferred from the leftmost bit to the right bit. Another important term is the data mode, and this refers to the direction of the clock's oscillating signal. If the signal is going from low to high, it is known as the rising mode, and if it is moving from high to low, it is known as the falling mode. Don't worry if it doesn't make sense now. We will look at it again when we discuss the working of SPI. Lastly, there's clock divider, which adjusts the clock frequency used in data transmission by a factor usually between 2 and 128. For example, if the clock speed is 16 megahertz and you use a clock divider value of 8, then the clock speed, and thus the data transfer rate, will become 16 divided by 8, or 2 megahertz. This clock divider value is used as the SPI can operate at millions of bits per second, which may be too high for some devices. To accommodate such devices, the clock divider value is used to adjust the data transfer rate. Now that we have some understanding of the SPI protocol, let's compare it to the UART protocol. Compared to UART, the SPI is faster because it supports higher throughput and doesn't require start and stop bits. It also requires a simpler hardware setup. However, SPI also requires more wires and is not as well suited for long-distance communications as UART. The SPI is used to transfer data between the controller and devices like the shift registers, sensors, the SD card, and many more. Let's take a closer look now at how SPI actually operates. In this diagram, the upper line is the clock line and the below one is the data line. The arrowheads on the clock line denote that the data mode is rising, that is, the data will be sent on the data line when the clock signal moves from low to high. During idle time, both the lines are in high state. To start the data transmission, in step 1, the controller sends an oscillating signal on the clock to the peripheral or the receiver, indicating that a transmission is about to start. In the second step, data is sent on the rising edge, in our case, in either LSB or MSB mode. Again, like before, if the data to be sent is capital P and the mode is LSB, 4 zeros followed by 1010 would be sent. Finally, once data has been sent, in step 3, both the lines go idle or prepare for the next bit. Let's now look at the wiring and see how in practical terms you might connect two devices using SPI. For an SPI transfer, 4 wires are needed. The SCK, or the serial clock, is the clock line. PICO and POCI are the data lines. PICO stands for Peripheral In Controller Out and sends data from the controller to the peripheral. POCI stands for Peripheral Out Controller In, and it is the opposite. It is used when the peripheral wants to reply back to the controller. Lastly, the CS, or Chip Select line, is a line used by the controller to let a specific peripheral device know that the data will be sent to it. Finally, remember that the controller controls the clock and the Chip Select line, whether the data transfer happens on the PICO or the POCI line. If you would like to get into more detail about the SPI protocol, we will add a few links in the resources section for you. In the next video, we will wrap up this mini section on input-output and the communication protocols by looking at another serial protocol called the I2C. See you there.